So we just saw the September equinox recently, and one of the things I've noticed is that every 6 months now, certain flat earth channels go into major damage control, trying to explain the equinox away on a flat earth. Now we all know that it is impossible, and in my previous challenge, I gave them the opportunity to show the equinox sun angles on a physical model, and they were unable to do so. Some of the explanations and videos I'm seeing are absolutely ridiculous, and this one I'm looking at here was a video I put out 18 months ago after the March 2017 equinox in response to a video from a flat earther who was trying to explain away the equinox. And the way he tried to do this was by using Google Earth and drawing great circle lines from a single line of longitude and identifying that they will eventually cross the equator. Now, that is absolutely true because a great circle line starting in an easterly direction from any line of longitude will cross the equator. And the reason for that is because we live on a ball. It will actually cross the equator after traveling 90 degrees of longitude. When you travel a further 90 for a total of 180, you will be in the opposite hemisphere at a similar latitude to which you started. After going 270 degrees of longitude, you will cross the equator once more, and after 360 degrees, you will arrive back at your starting point. That is how a great circle works, because we live on a ball. And the big mistake, of course, is that if we are traveling east at all times, we are not following a great circle path. If we start at this point here and we travel east, we would actually be traveling along that line of latitude. If we start at this point and travel east, we are traveling along this line of latitude. A great circle is not the same as a latitude line except for the equator, because the equator itself is a great circle. But at any latitude north or south of the equator, the line of latitude itself is not a great circle, and therefore it will not cross the equator. It will run parallel to the equator, and that is what east is. It is 90 degrees from geographic north. A great circle line is constantly changing direction, which we'll take a look at some of my flight planning software, and we can confirm that. So what I have drawn here is a great circle line from the prime meridian, longitude 0, latitude north 45 degrees, down to a position on the equator at east 90 longitude. And you can see that this great circle line starts in an easterly direction and then crosses the equator at an angle quite different to east. Now, if we put that into my flight planning program, you can see here is the point 1, latitude 45 degrees north, longitude 0 east, point 2, latitude 0 on the equator, and longitude 90 east. And that gives us a distance of 5,400 nautical miles. And I have specified a leg distance for the flight plan of 100 nautical miles for each sector. And you can see that the initial course is 090, but very quickly deviates from that. We then have 092, 093, 095. It changes to 100 degrees and continues turning further south as we continue. And you can see that is true in Google Earth when we draw that same line. So this line is not showing us east at all. It starts east and very quickly changes direction, because that is how a great circle works. It is completely incorrect to use the ruler tool in Google Earth as an explanation of what happens when you go east. In reality, when you go east from this point, you will just go parallel to these lines of latitude. Now, I think anyone who has been dealing with flat earthers long enough will agree with me that they are notoriously weak at three-dimensional geometry. What we can do now is take this point and move it to any position on the prime meridian, and the same concept is going to be true. The great circle will commence going 090 east, but it will deflect to the south until it crosses the equator. And the further north we are, the more that deflection is going to occur, even though the initial heading is 090. What is significant also is that the distance from this same point on the equator at 90 degrees longitude to any point on the prime meridian is going to be about 5,400 nautical miles. Now you will see slight differences there. That's just in the accuracy of how I'm moving the mouse. And there will also be a slight increase in the distance near the equator compared to going up to the pole. And that is because of the oblate spheroid shape of the Earth. And we can demonstrate the same concept in this flight planning program just by changing the latitude only of position 1, which is doing exactly the same thing as moving that line up and down on the prime meridian. By changing the latitude, you can see that the distance of 5,400 nautical miles is not going to change. What will change is how quickly that course deviates from the initial 090 east direction. Let's move up to 85 north latitude. The distance did not change, but you can see the course changes more severely towards the south for each sector. If we put the latitude down very close to the equator, 5 degrees north, again, the distance does not change, and the course still changes, but only by a very small amount. And this is why it is a complete red herring for a flat earther to use Google Earth and claim that the changing direction of a great circle somehow explains the equinox. It is completely irrelevant to the angles of the equinox because we're looking at a great circle track on a ball. The Equinox Sun angles at sunrise 090 and at sunset 270 have absolutely nothing to do with the changing direction of this great circle. And so once again, this is yet another demonstration that flat earthers just don't understand the equinox geometry at all. They don't even understand why it is a problem for the flat earth. And in demonstrating this concept of the great circle line crossing the equator when it starts east at any point on a line of longitude, they're actually showing us and confirming the geometry of a ball, even if they don't understand it. It's quite hilarious, to be honest. And what is also hilarious is when you look at the title, Sunrise and Set on the Equinox, explained on a flat earth, and the entire video is done using Google Earth, which is not a flat earth, it's a ball. And then later in the video, they go on to talk about the magnetic variation, the declination changing from various points on the Earth. Another red herring, completely irrelevant to the equinox angles, which are all based on true north. The magnetic declination and variation from various points on the Earth are completely irrelevant to the equinox geometry. So nice try, flat earthers, but again, all you have done is demonstrate to us that you don't understand the angles of the equinox.